Hello everyone, now we're going to talk about signals and slots, and this is a really useful feature of Qt framework. And we're going to begin with the concept of function pointers and callbacks. These advantages of callbacks, what are the signals and slots, and how they can be used instead of callbacks. And a quick example of their use in our project. So let's start with the Q definition of a function pointer. And a function pointer, if we search the web, a function pointer stores the address of a functionality that can be called anytime, even as a function argument. And a function pointer are used as arguments to callbacks functions. And if you had used the C++ Windows API, callbacks are invoked, especially when a particular event happens. And event is similar to an interruption, hardware interruption, but that is handled in the Kiwi. Imagine that we have a loop that handles the mouse movements, and interface redrawing by events. If an event happens, then the system calls a callback function to process this event properly. Let's notice that the callback function returns no value. Let me just close this. Notice that it didn't return any value. It does not return any value, and takes two arguments always as its arguments. The first one is the object that triggers the event, and the second one is the object that contains that event. And according to the Q documentation, there are two principal issues and problems with callbacks. The first one is there are no type safes. You don't have any way to identify the type in runtime. And second is that they're strongly coupled by the processing function. So therefore, Qt by those disadvantages recommends the use of signals and slots instead of the using of callbacks. In brief, signals and slots is a mechanism to communicate Q objects from each other. And a signal is a message presenter. It's presented in the class definition. And whenever we want to emit something, any event, we can call a signal, and even we can append some parameter to pass to the slot. And the slot is a member function that can be called as a normal function actually. Is the response when a signal is emitted. And it can also handle the parameters from the signal. Qt had defined different signals and slots by default that you can use depending on the type of your Q object, whether it's a Q widget or any other Q object derived class. And you have a set of different signals and slots, but Qt also gives you the opportunity to define your custom signal and slots. As an example of the use of a signal slot, we're going to connect the widget that we create, such as the cover widget, the software widget, and so on. And we're going to connect them between them. First, we're going to connect when a button has been clicked to our custom widget, and also we're going to connect the signal defined in the inference kernel. To notify that the user interface had been finished to process the knowledge base. Then the UI will determine how to handle this information. So let's begin with the implementation. And we're going to move to the C view. And we're going to code in this part. And let me just type it. Connect function. This function serves as a static connection between signals and slot. So first argument of the connect function is a pointer, and it's a sender, and it must be a Q object. In this case, it's an inference kernel. If you remember, if you go to the definition, the inference kernel, we define it as a Q object, adding this macro. The second argument is the signal to be used. Let's notice that the signal macro, this one that we're going to define here, gives a specific way to make the meta object compiler identify signals and slots. And the function inside the signal, in this case, is atom value demanded. Is converted to a string and queued at one number to be identified as a signal. Otherwise, if the function is inside a slot macro, it is also converted to a string, but at a 2 to be identified as a slot. Okay. The third parameter then is the context. And in this case is the CView widget. As we call slot, we want to define a new slot called on atom displayed. So next we need to define the new slot, call it on atom displayed with a 3 index as argument. So we want to define a new protected slot void on atom displayed. Now with this slot we're going to finish the statement of connect. So we can return to CView and finish it. Just don't forget the parentheses with the int. And if you try to compile this solution, the compiler actually needs to send an error because we haven't defined the slot. We have on atom displayed undefined reference. So let's define it. Before starting the implementation, we need to define 2 new methods that we're going to need. These methods are needed to access the tree index and symbols from the inference kernel. So we need to move to the inference kernel header and define the public q vector just return the this is for the symbols. This function will have the pairs processing from the knowledge base to the message box. And I'll show you later about the way our programming will get the values from the client is from a dialog box. In this dialog, we're going to ask our user a probable issue in the car. For example, if there is a black smoke in the car, make links also gives 3 options to our client, yes, no, and I don't know. Where the user says yes or no, this value responds to questions that are saved in the inference kernel to infer a conclusion. And if the user says I don't know, we skip the question and save it to future revisions. So the first step is to get the position. So it's in position. Remember that is a vector, and the element has two members. Function is first and second. Seems like a map. By this position, we can get the string defining the question to ask, because the inference kernel rules the format join sentences by underscores. So we should remove them to show them properly to the user. We can use a function in the QString, and this function is called replace to do so. So we defined string symbol. Replace the underscore swap blank space. And the creation, the dialog box, I will put it in the next video. So see you soon.